Alright, good day. Today we are going to learn the multiple linear regression using SPSS. Objective of today's lesson is model the multiple linear regression using SPSS, report R squared and adjusted R squared, which is goodness of fit measure of regression model, test the overall significance, test the individual significance of regression coefficients. Okay, we go to the SPSS variable view, create dependent variable y, two independent variable named x1 and x2. So click to the data view, we have variable y, x1, x2. You can either key in the data or copy the data from Microsoft Excel. We select and then Ctrl C to copy, and then we move to SPSS, Ctrl V to paste it. To model the multiple linear regressions, we click the Analyze menu, Regression options, linear, sub options, and then clicks variable y is now selected. We click to move it to dependent variable. Click on x1, move it to independent variable. Click x2, move it to independent variables. Then we click statistic. The estimates checkbox is on. Will provide the estimation of the regression coefficient, beta naught, which represent the intercept of y, beta 1 represents the coefficient of x1, beta 2 which represent the coefficient of x2. If we would like to include the confidence interval for beta naught, beta 1 and beta 2, we check on confidence intervals. Model fit will give the determination of coefficient R squared, adjusted R squared, and ANOVA table. And then descriptive statistic will provide the mean standard deviation of y, x1 and x2. Then we click continue and then OK. So this is a descriptive statistic, provide the mean of y, x1, x2 with their respective standard deviation. This is a coloration matrix, which give the Pearson coloration amongst the x1, x2, x1 and x2, and these are actually symmetrics. And then we have the model summary provides this is a magnitude of the Pearson coloration coefficient. This is a determination of coefficients R squared, adjusted R squared. ANOVA table which provides the overall hypothesis testing. Which tests on the H-NA beta 1 equal to beta 2 equal to 0 versus alternative not all beta I equal to 0. Since significance of f here less than 0.005, less than 0.05, less than 0.05 with 5% significant level, 5% significant level, we reject null hypothesis. We reject null hypothesis because significant f less than 0.05. We reject null hypothesis. There is sufficient evidence to conclude that at least one predictor is useful in explaining why, but we don't know whether beta 1 or beta 2, or mean the x1 or x2, we don't know which variable. And then for the individual significant testing, we can refer to the significant value, significant value for this is a beta naught, beta 1, beta 2 against all the significant value are less than 0.05, then the individual hypothesis testing, which state that the null hypothesis states beta j equal to 0 which means no linear effect of xj on y, versus alternative beta j not equal to 0, which imply linear effect of xj on y-axis. Since all significant value of beta naught, beta 1, beta 2 are less than 0.05, hence each we can conclude that each independent variable is significantly affects the dependent variable at the 5% significant level. And here, in the significant value less than 0.05, reject null hypothesis. This significant for overall hypothesis testing. This is for individual hypothesis testing. Besides, we can use the 95% confidence interval for beta naught, beta 1, beta 2. If the confidence interval does not contain 0 against the individual hypothesis testing of beta j equal to 0 is rejected. Hence, there is sufficient evidence that each independent variable is significantly affect the dependent variable at the 5% significant level. And then remember our objective, test the overall significant using the significant f value from ANOVA table. Test the individual significance of regression coefficient using the significant value below the ANOVA table or the confidence interval. And then we have report the R squared, adjust the R squared model. How to get the model or the value of beta naught, beta 1, beta 2. Under the table below ANOVA table, you see that this is actually the coefficients. So mean 30.994 is actually the beta nodes, 0.861 is beta 1, 0.335 is actually the beta 2. Hence, the multiple linear regression model is actually 30.994, the intercept, plus the coefficient for x1 is 0.861 times x1 plus 0.335 times x2 and this is a standard error for beta naught, beta 1, beta 2. This is a t statistic for beta naught, beta 1, beta 2. The t statistic is actually your beta naughts divided by standard error beta naught, we get the t statistic for beta naught. Similarly, beta 1 divided by standard error beta 1, we get the t statistic for beta 1. And then the beta 2 divided by standard error beta 2, we get the t statistic for beta 2. If we use the t statistic, we can compare if the t critical value. If the t statistic greater than t critical value, then the H null is rejected. Mean the individual hypothesis testing, H null is rejected. That is using the manual way, or we can use the significant f value, significant value, or in the Excel this is actually referred as p value. For Excel, the ANOVA table, this significant f value used to test the overall significant, and for the individual significant we use a p value, but this p value is denoted as a significant value in SPSS. So with this we model the multiple linear regressions. We report the R squared, adjust the R squared, test the overall significant, test the individual significant using SPSS. In the model, get the coefficient beta naught, beta 1, beta 2 here, and then the R, this is R squared, adjust R squared, this is a use this significant if less than 0.05, reject the null hypothesis of beta 1 equal to beta 2 equal to 0. Implies that at least one predictor is useful in explaining why. And then for individual hypothesis testing, we can use the significant value or the p value for each coefficient. If less than 0.05, then we reject the null hypothesis that beta j equal to 0, implies that independent variable significantly affect the dependent variable at the 5% significant level. Okay, with this, thank you for your attention.